Hello, good people. This is Trockers. Welcome back. Okay, we have a problem on ordinary differential equation from ZIMSEC November 2004 paper 2. The question reads, find the general solution of the differential equation cosine of x dy of dx plus 2 sine of x is equal to 3 tan of x, right? 4 points were allocated there. Okay, so with this problem, guys, first things first, we need to see how we can separate the variables here since we have another term that is being added. So I believe for this problem, what we can do here is to move this up here, right? So when you move this to the other side, you're going to subtract. Then here you're going to bring down. So you're going to divide these and that like they are on that same side. Then we can what? We can then multiply by that. Okay, cool. So with that being said, let's go ahead and get started. Okay, so I'm going to rewrite this problem down. Okay, let me put it in red. So cos x dy dx plus 2 sine of x equal to 3 tan of x. We need to find the general solution of this differential equation, right? So I have my cosine of x dy dx plus 2 sine of x equal to 3 tan of x. So what we are going to do first is to subtract 2 sine of x from both sides, such that we remain with cos x dy dx is equal to 3 tan x minus 2 sine x. Remember, we are trying to separate the variables, so let's go ahead and divide both sides or all the terms with cosine of x, such that we remain with dy dx equal to 3 tan x over cos x minus 2 sine x over cosine of x, right? So from here, what we can do is to multiply both sides. So if I'm to separate this, I'm going to differentiate that is equal to 3 tan x 1 over cos it's secant of x, right? Minus, leave this one like that, cos x dx, right? So we need to integrate that. We need to integrate that. It's 3, so it's integral of 3 tan x dx, right? So now, guys, there's one thing I need to bring to your attention. If I have secant x here, which is equal to 1 over cos x, and we are to differentiate this. Remember, I'm going to use the quotient rule. So it's v du, it's this, right? Minus u. If we differentiate this, we get negative sign, right? All over this squared. So, sorry, if we differentiate it 0, this becomes positive sine x over cos x times 1 over cos x, which is tan x sec x. So if we differentiate sec, we are getting this. And when we integrate this now, if we integrate this, we should be able to go back to that point. So this implies that here y equal to, so this is now 3 secant of x, right? Then here, remember, guys, every time we differentiate this, remember when we differentiate function of this form, like first derivative over that, right? We get natural log of this plus in our integration constant c every time when we get that. So we see that if we differentiate cos, we get negative sign, right? So the answer here becomes minus 2 natural log of cos x plus c. Then we are done. So here, this is the integral of that ordinary differential equation. That's the solution, the general solution of that ordinary differential equation. So with that being said, guys, I'm signing out.